It was supposed to be the next leap after the fastest air-breathing aircraft ever, a follow-up to a record breaker. The X-43C was imagined as a sleek, hypersonic drone that could scream across the edge of space, powered not by exotic lab fuel but by something closer to real jet fuel. It was bold, maybe too bold. Yet this is the part most people never hear. The engine was built. The dream was alive. Then, before it ever flew, the program vanished. The designation became more myth than machine, often confused with another shadowy label, X-42, which only deepened the mystery of a drone that never took off. So why did this promising aircraft die before its first flight, and which jet ended up taking its place? Today, we uncover the lost story of X-43C, the aircraft that shaped hypersonics from behind the curtain. To understand the X-43C, you have to start with its older sibling. In 2004, a tiny unmanned research drone called the X-43A punched through the upper atmosphere and hit Mach 9.6. It was the fastest air-breathing aircraft ever recorded. NASA celebrated, engineers cheered, and headlines compared it to a rocket without wings. The logical next step was obvious. If you can light a scramjet with hydrogen for seconds, then maybe you could build something bigger and make it run on fuel that real weapons could carry. That idea became the X-43C. It would be longer, heavier, and most importantly, driven by a hydrocarbon scramjet. Not exotic cryogenic hydrogen, but dense fuel like the Air Force wanted for future hypersonic missiles. The plan was ambitious. Launch from a B-52, boost it into the high supersonic range, then let the scramjet take over and collect minutes of flight data instead of seconds. This is where the story should lift off. Instead, it stalls. Because while engineers were preparing hardware, someone far away from the wind tunnel needed money for something else. That is where the X-43C began to die. But the mystery gets deeper because around this time, a different label started appearing: X-42. Search long enough through aerospace rumor threads, and you will see people mention X-42 like a ghost weapon. Some claim it was a hypersonic strike drone. Others say it was a space plane. The truth is much less cinematic. X-42 existed as a designation, but it was tied to a propulsion test effort rather than a full vehicle. Think of it as a locked room in a classified hallway. You know it is there, but you are not allowed to see inside. Yet the mix-up between X-42 and X-43C created a myth. People assumed X-42 was the secret successor to the scramjet program. That confusion is actually useful here because it reveals something about this era. Hypersonic research was fragmented. Pockets of money, competing priorities, and projects that shared technology without sharing credit. X-43C was the practical child. The smaller experiments showed it could be done. X-43C was meant to prove it could be done for longer and with fuel that mattered. So what went wrong? To answer that, you need to look at NASA's budget table, not the airframe. Hydrogen is a wonderful fuel for bragging rights. It burns fast and helps you hit headline speed records. It is terrible for real weapons. You need tanks, refrigeration, and plumbing that troops cannot drag into combat. That is why the Air Force was pushing for something else: a fuel-cooled scramjet that ran on hydrocarbon fuel. The fuel would enter cold, cool the engine surfaces, crack into smaller molecules in the process, then ignite in a supersonic shockwave. It was elegant and brutally difficult. The X-43C was the vehicle meant to prove this. It would ride a booster to roughly Mach 5, then let the scramjet light itself and accelerate under its own power for minutes, not heartbeats. That change matters. Seconds of scramjet combustion are a science fair demo. Minutes are the first step toward cruise missiles, drones, and reusable stages. Engineers actually had the scramjet built. A flight-weight engine existed and was being integrated. The aircraft itself was real enough to appear on schedules. Then the axe fell. Because at the same time NASA was celebrating speed records, Washington was reorganizing space priorities. And in a fight between glamorous human missions and a drone experiment hidden in budgets, the drone rarely wins. By 2005, The agency was preparing for shuttle retirement, new lunar goals, and a sweeping shift of money toward manned spaceflight. Something had to go. In the paperwork, the cut is chilly and matter-of-fact. Termination of the X-43C demonstration vehicle. The scramjet work would pause. Funding would shift. All the energy that was meant to turn the X-43A record into operational capability evaporated. Engineers had pieces of a future. Now they had nowhere to fly it. But here is where the story bends. The scramjet that survived inside this canceled program did not end up in storage. It was handed off. The Air Force and Boeing took the hardware and seeded a new demonstrator called X-51 Waverider, the aircraft that would later clock over 200 seconds of scramjet-powered flight. If the X-43C was a canceled movie, X-51 was the sequel that actually aired. Which raises a question. Did X-43C really fail? Or did it simply become something else in a different uniform? Hold that thought. Because the real twist is what happened when X-51 flew and the rest of the world noticed. If you enjoy uncovering the hidden histories behind iconic aircraft, tap subscribe. More stories like this are coming, and you will not want to miss the next forgotten prototype that shaped modern aviation. The X-51 did not appear out of thin air. It inherited the orphaned scramjet work NASA left behind. The Air Force Research Laboratory partnered with Boeing and Pratt & Whitney to refine the engine, package it under a B-52 wing, and fire it with a solid rocket booster. When X-51 lit its scramjet in 2010, it finally did what X-43C was built to prove. It flew on hydrocarbon fuel for hundreds of seconds at roughly Mach 5. It was not a splashy viral moment. It was a quiet milestone that confirmed operational hypersonic flight was practical. That performance reshaped expectations. Instead of scramjets being scientific tricks, they became prototypes for real weapons. Engineers now had data on ignition stability, shock control, and fuel cracking under flight loads. Politicians suddenly noticed too. Global rivals were developing hypersonic systems of their own. The US had stumbled into a lead, but it nearly lost it when X-43C was canceled. In a twist you could not script better, the program that lived was not the one that began the journey. It was the one that inherited its parts. Which raises the uncomfortable question. How many breakthroughs get buried simply because another department needed money more? The answer arrives in the next phase of this story. Imagine the X-43C actually flew in 2006 or 2007. Engineers would have had years more scramjet data. The Air Force could have field-tested hypersonic demonstrators sooner. And the gap between experimental aircraft and deployable systems might have narrowed before adversaries noticed the opportunity. Instead, momentum splintered. The US paused, China and Russia ramped up, and the race became urgent rather than comfortable. In this alternate timeline, the X-43C might have seeded hypersonic reconnaissance drones, long-range strike concepts, or even reusable first stages. Politics redirected it all. That is the irony. Sometimes the program with the most potential dies quietly while the one that survives ends up being credited as the pioneer. But the fingerprints of X-43C are everywhere. Its scramjet work became X-51. Its goal of long-duration hydrocarbon-powered flight is now standard language in hypersonic roadmaps. And its cancellation is often cited as a warning about breaking continuity in advanced research. So X-43C never flew, but its ghost lingers in every briefing about hypersonic weapons today. The lesson? Sometimes the breakthrough is not the aircraft that breaks a record. It is the one that never left the ground. Remember X-42? The mysterious designation that spawned more rumors than facts. It never revealed its full identity, but its presence matters because it fits a pattern. Highly classified propulsion tests often borrow X-plane labels without ever becoming public vehicles. They influence other programs in the shadows, then disappear. That is why enthusiasts built myths around it. It looked like the missing link between scramjet research and classified hypersonic work. In a strange way, X-42 became the symbol of all the projects we never see. The ones that do not get documentaries or record banners, yet quietly move technology forward. X-43. C is one of them, except we actually know enough about it to connect the dots. X-42 represents everything we do not. The deeper you follow hypersonics, the clearer this becomes. Progress is rarely a straight line of clean successes. It is a web of dead ends, canceled demos, budget refugees, and sometimes mislabeled mysteries. So, X-42 is more than a rumor. It is a reminder that the hypersonic landscape is full of ghosts. Some never existed. Some flew under different names. Some, like the X-43C, lost their wings but lent their heart to someone else's aircraft. And the story is not done yet. If you trace the lineage of modern scramjet programs, you keep finding fingerprints from projects that never saw daylight. The Air Force's current hypersonic ambitions rely on fuel chemistry research pioneered under high-tech. Wave Rider flight data validated ignition models that X-43C was supposed to explore. Industry studies still reference fuel-cooled scramjet architectures first mapped for X-43C. And international rivals regularly cite US cancellations as proof that persistence matters more than brilliance. So was X-43C a failure? Only if you only measure success by flight hours. The engineers behind it built something that survived longer than its label. The scramjet lived on. The ideas became roadmaps. And the unrealized aircraft became a cautionary tale about cutting research too early. That is the strange legacy of X-43C. It changed hypersonics without ever taking off. You could argue it succeeded by failing, because without that cancellation, there may never have been an X-51. And without X-51, the current hypersonic race would look very different. Which leaves us one final thread to pull. If the aircraft that never flew shaped the future, what does that mean for the secret programs that never get screenshots or headlines? That answer lies in the last act. So where does that leave the X-43C? It never roared to life in the upper atmosphere. It never appeared in glossy rollout footage or test range hype reels. On paper, it failed. But that view is shallow. Its engine survived. Its data requirements shaped the X-51 mission profile. And the cancellation became a lesson every hypersonic program studies before it asks for funding. The truth is that aerospace progress looks glamorous only in hindsight. Up close, it is bruised knuckles, shelved prototypes, and technology migrating to aircraft that never share credit. X-43C became that kind of ancestor. A project that mattered because it did not finish. Its scramjet set the stage for the first operationally useful hypersonic flight. Its absence accelerated urgency when rivals emerged. And its ghost shows up every time someone warns against throwing away flight-proven research. In the end, X-43C never took off, yet its ideas did. They flew faster and further under a different designation. So the next time a headline announces a breakthrough hypersonic test, there is a good chance you're watching a piece of X-43C finally having its moment. If you want more untold stories like this, subscribe and tell us which forgotten aircraft you want next.